Battery technology for EVs is always evolving and never really stops improving. But when it comes to Tesla's 4680 battery, it looks like it may have already reached its peak. Simply put, it's hit a new high with major breakthroughs, delivering maximum energy output while cutting mass production costs by as much as 50%. Thanks to these improvements, Tesla has confirmed that the 4680 battery will be used in the Model Y going forward, and a super long-range version could be launched very soon. This is honestly a huge turning point because, as you probably know, the 4680 battery has only been used in the Cybertruck for the past 2 years, and that truck definitely isn't cheap. Because of that, many people, even industry experts, started to believe that the 4680 battery technology was a complete failure. CATL's CEO Robin Zung even said at one point that the 4680 battery would never work. But honestly, that claim feels pretty ironic because up to now, CATL still hasn't produced a battery that's better than Tesla's 4680. It remains one of the best batteries in the world today. And with the latest upgrades, it's been pushed to an entirely new level. One that could take CATL many more years to catch up to. So let's dive into the latest updates on the 4680 battery and why it might be considered the holy grail of batteries, at least until solid-state batteries truly go mainstream. Tesla first publicly unveiled the 4680 battery at Battery Day in September 20th, when Elon Musk called it the biggest leap forward in lithium-ion battery technology ever. From the very beginning, Tesla wasn't just talking about a new battery cell. It was talking about a complete overhaul of how batteries are designed, manufactured, and integrated into electric vehicles. The name 4680 comes from the physical size of the battery cell, 46 millimeters in diameter and 80 millimeters tall, significantly larger than the 2,170 cells that were widely used at the time. But the real breakthrough wasn't the size. It was the completely different design philosophy behind it. So what exactly makes the 4680 battery so special compared to a regular lithium-ion battery? First, we need to clear something up. The 4680 is still very much a lithium battery. Some people think it doesn't use lithium at all, but that's just not true. It still contains lithium, and it even uses nickel and cobalt. What really sets it apart from traditional lithium-ion batteries is its tablet design. You've probably heard about this already, but not everyone fully understands what it means. In a conventional battery cell, there are small metal tabs that connect the electrodes to the terminals. Those tabs become bottlenecks for electrical resistance and heat buildup. Tesla completely eliminated that design, allowing current to flow more evenly across the entire surface of the electrode. The result: less heat, higher power output, faster charging, and improved durability. On top of that, the internal structure is more efficient, which reduces unnecessary materials and leads to higher energy density. The last time we heard official numbers, the 4680 battery had an energy density of around 272 Wh per kilogram. And it doesn't seem like that number has changed much since then, at least not publicly. There haven't been any reports of even minor upgrades. But here's the thing. Even at 272 Wh per kilogram, the Tesla 4680 cells are still considered among the highest energy density batteries in the world that are mass-produced. Simply increasing the cell size alone allowed Tesla to drastically reduce the number of cells needed in each battery pack. That means fewer wires, fewer welds, and much lower assembly costs. Tesla began producing its first 4,680 cells in late 2021 at its pilot facility on Coe Road in California. But this wasn't full-scale commercial production yet. It was a pilot line where Tesla was both manufacturing and learning how to manufacture at the same time. Those early cells were mainly used for internal testing, evaluating durability, energy density, fast charging capability, and especially how stable the cells were when integrated directly into the vehicle structure. This testing phase lasted nearly 2 years, and it wasn't until 2023 that Tesla finally started deploying the 4680 battery in the Cybertruck. Okay, on the surface, this all sounds like a smooth journey from research to production to real-world use. But in reality, the 4680 battery hasn't been nearly as perfect as many people expected. That's exactly why it spent years being used only in the Cybertruck, why costs stayed relatively high, and why production ramped up so slowly. We mean if a battery is truly that good, it should be showing up across multiple Tesla models, right? The truth is from 2020 to 2023, Tesla's 4680 battery only used a dry anode while the cathode was still made using the traditional wet process. This essentially created a hybrid version of the battery far from Elon Musk's original vision. Tesla simply couldn't fully master the dry process cathode, which is the most complex and expensive part of the 4680 battery. Because of that, Tesla was forced to keep massive drying ovens and toxic solvent handling systems in place. In the end, that wiped out many of the promised advantages in terms of factory footprint and cost reduction. This technical bottleneck caused the earliest batches of 4,680 cells to have lower energy density than the older 2,170 cells, pushing Tesla straight into what many would call a production hell. Reports showed that early on the battery materials were prone to cracking, had poor adhesion, low yields, and high defect rates, driving real-world costs far beyond initial expectations. Elon Musk himself admitted that scaling dry electrode technology was much harder than expected, and that even a tiny deviation could break the entire production line. That's why many experts, and even Cattle's CEO, publicly claimed that the 4680 battery was an unrecoverable failure. Given all of that, Tesla had little choice but to use the Cybertruck as a real-world testing ground for the 4680 battery. The Cybertruck has a completely new vehicle architecture, a large and heavy body, a high price point, and enough margin to absorb the cost of an unoptimized battery. On top of that, Cybertruck production didn't need to be massive in the early stages, which allowed Tesla to manage risk if the battery ran into problems. By contrast, high-volume models like the Model 3 and Model Y simply couldn't afford to adopt an unstable battery technology. Even a small issue could affect hundreds of thousands of vehicles per year. And that's a risk Tesla wasn't willing to take. Because of all that, for nearly 2 years, the 4680 battery was almost exclusively associated with the Cybertruck. That created the impression that this technology